Hello students. So today we will study about the sequencing from production and operation management. In this video we are going to cover the Johnson's algorithm and which is used for n job one machine, n job two machines. We'll also study about tie breaking rules with example, and we'll start with the assumptions in sequencing, and at the end we'll cover how to calculate the total elapsed time and the idle time. The basic assumption in sequencing is that one machine can handle only one job at a time. Processing sequence cannot be altered. Processing time are independent of the sequence and the machine that is used, and if we start with one job, we have to continue till its end. We cannot stop in between. Now let us study some rules which are used for n job and one machine. See, certain machines are very costly, like you can say a 3D printing machine for metals, maybe tool cutting machine. We have seen in our industrial visit one single machine which was used for tool coating costing 13 crores. So we cannot repeat such machines. So how to schedule the jobs on these machines? We will study here. One rule is first come first served. Whichever the order we have received first, we are going to process it first. That can be the simple criteria, but we have to give the due consideration to the due date also. So the another criteria may be whichever is the job having earliest due date is to be done first. Then what we'll do is we may select jobs which are having shortest processing time. So that may be another criteria for selection of jobs. Then other criteria may be the longest processing time, and whichever is the job having longest processing time, let us finish it first and then we will schedule the other jobs. It may be also one of the criteria. And apart from this, the criteria may be preferred customer order. Sometimes whatever the order we have already done, but if we receive the order from a customer who is a regular customer who gives us a major order, so for such customers we may choose an option of preferred customer order, and his job, their job, we may take it first. Then let us study about the Johnson, who has developed an algorithm for n job and m machine. What he has mentioned is that the minimum processing time, if it is there for the first operation, we have to sequence that job first, and if the minimum processing time is for the last operation, then we have to place it last in sequence. Now let us try to understand this with an example. So let us take an example. Here we are having 5 jobs which are to be sequenced optimally. Now you will find, if you look at this job, what you will find, the shortest processing time amongst all is 4. So that job, and it is for the last operation, so it is sequenced last. Once that job is sequenced, we cannot consider it for the further process. Now out of remaining, we have to search for the shortest processing time, and you will find the shortest processing time is 6. It is for the 4th job, and it is for the first operation, so we have scheduled it first. Now out of remaining 3, we have to search for the shortest time, and shortest time you will find is 8, and it is for the second job, so that job should be placed last in sequence. Out of remaining 3 and 5, shortest time is 11 for job number 5, and it is for the first operation, so shortest time is 9 for the job number 3 for the first operation, so we will sequence it first, and then finally the last position we will give it for job number 5. Sometimes there may be tie. In the earlier example, there was no tie between the processing time of job, any of the job on any of the machine, but there may be tie. So we'll try to understand how to break this tie with an example. Here there are 6 jobs, so we'll search for the shortest processing time. We have found the shortest processing time is for the job number 2, and it is 2. At the same time, the shortest processing time is for the job 5. So you can see here there is a tie, shortest processing time for machine 1 as well as machine 2. In this case, the tie can be broken using this rule. If the shortest processing time occurs for the first machine, it is to be sequenced first, and if it is for the last machine, it is to be sequenced last. And so we have seen this shortest time for the first operation, so job 5 is placed first in sequence. This shortest time is for job 2, so we have placed it last in sequence. Now, so these two jobs are now, we have done the sequencing. Let us take up for the other jobs. Now these two jobs we have already done. Now we will find 5 is the shortest time, and that shortest time tie occurs for the first machine itself. So whether to place job number 3 first or job number 6 first. Now here because of tie we are confused, but as the rule says, if there is a tie for the shortest first, look at the shortest second operation. Now shortest second operation is for the job 3, so job 3 must be placed first in sequence, and then job 6 is to be placed. So we have seen here job 3 is first kept first in sequence, and then we have scheduled sequence job number 6. Let us see. For now we have done the sequencing for these 4 jobs. Now go ahead. Here what we'll find is, now these 4 jobs are already done. Out of remaining 2, job number 1 and job number 4, you will find shortest time is for the last operation. Now again there is a tie, so which is to be kept last in sequence. For that again you have to refer back to the shortest time on the first machine, and if there is a tie for the shortest time on second machine, you have to place that machine last in sequence, which is having shorter processing time on machine 1. So you will find job number 1 is having shorter processing time compared to job number 4, so we will place job number 1 last in sequence. So we will find job number 1 is kept last in sequence, and then we have kept the job number 4. After doing this, we may have to now decide what is the total elapsed time for all these jobs. So these are the 6 jobs. We have solved this example and we found that this is the optimal sequence. But what is the total time, elapsed time, and what is the idle time for each machine? For that we have to prepare the chart, and from this we can prepare the Gantt chart also. So look here, first job number 5 is kept first in sequence. It requires 2 units on machine 1 and 11 units on machine 2. So we will find we have scheduled first 0 to 2 on machine 1 and 2 to 13 on machine 2 because it takes 11 units. Then we have to place job 3 in sequence. So next job is job 3. It requires 4 units on machine 1 and 9 units on machine 2. So as soon as job 5 is finished on machine 1, we can take this load job number 3. So after job 3 is loaded, it takes 7 units. Then we have to take it to the machine 2, but machine 2 is not free. It is busy in doing the job number 5. So it will be free after 13 units, and then we'll load job number 3, which takes 9 units. So it will be finished after 22nd units. Now next job to be placed is job number 6. Job number 6 requires 4 units on machine 1 and 12 units on machine 2. So you will find load it on machine 1 first. After 7, once job 3 is over, after 5 units, after 12 units it will be ready. But again job has to wait because machine is not free, and this machine requires 12 units for job 6. So after loading on 22nd units, it will take 34 units. Then we have to load job number 4 on machine 1. You will find it requires 10 units. So after 12 units, job 6 is over. It requires 10 units for job 4. So after 22 units, job 4 is over. And then it will go on the machine 2 once it becomes free, that is after 34 units, where it requires 6 units. So it will be finished after 40 units. Then as per the sequence, we have to place job number 1. Job number 1 requires 7 units on machine 1. So it will be finished after 29, and it will take 6 units. So it will be ready after 46 units. Finally, the last job to be kept in sequence is job number 2, which requires 8 units on machine 1. So it will finish by 37. It requires 2 units on machine 2. So it will finish by 48. So we will find once we finish all 6 jobs, the total time requires is around 48 units, and you will find machine 2 has to wait. All other time job has to wait, but machine 2 has to wait initially for 2 units, and that is the only idle time for the machine 2. So this is how we have to do the calculation of the elapsed time as well as the idle time. In the next part, we will study how to do scheduling. Thank you. Keep watching.